So now we want to calculate that what is the resistance of our spherical surfaces with hollow, which is partially hollow, where the inside radius is A and the outer radius. Okay. Oh, you want me to scroll up? Yeah. So this part we did in the last class. Were you not there? Yes, Chavez, did you not note down this part? Is this okay, Chavez?
Yes, sir.
Yes, I'm asking Chavez. So maybe, oh, done. Now, yeah. So now we want to calculate the resistance of a sphere which is hollow from the inside. Oh, you just want to check, yeah. So inside radius is A and the outer radius is B. So we have a sphere, right? And this is hollow from the inside. So now we have to calculate the resistance between these surfaces. So let's say you have a ball, right? And you partially gauged out these portions. So let's say this is A. So inside surface is 4 pi A square and outside surface is 4 pi B square, right? And now you want to calculate the resistance between these curved surfaces, right? So then what we will do? Again, we will use the same analogy. So we will assume a very thin spherical surface in between, which is of radius x, right? And then its length is dx, small length is dx. Then the small resistance, so the small resistance of this sphere would be rho dx and divided by the area of cross section of this part. So that is 4 pi x square. Right? Is this part clear, guys? Is this clear? So we have assumed a strip, right, whose radius is x and its length is a small distance. So we have assumed this kind of very small strip, right? And this is dx, and this surface is x. So we are calculating the resistance between these surfaces. So that would be the small resistance. And then we will integrate from here to here. So that will give the whole resistance, right? Okay, so then we integrate these things, then we'll get rho dx and 4 pi x square. So the limit would be a to b, right? So again, I will ask you guys that what would be the integration of 1 by x square? What is that? Rho is constant, 4 pi is constant. So this is a to b dx by x square. What is the integration of 1 by x square? What would be that, guys? Tarif and Shavis. Text. Yeah, what would be the integration, Tarif? minus 1 by x. Okay. Yeah, Tarif. So this is x minus 2, right?
Yes, sir.
So this integration would be minus 2 plus 1 divided
By
by minus.
minus 2 plus 1.
This
So
is
x minus 1 by minus
so
1.
this is minus 1 by x as Shabe is. Yeah, good everyone. So this would be this. So this is minus of 1 by x and the limit is from b to a. Right. So then this is minus of rho by 4 pi and this is 1 by b minus 1 by e. Right. So this would be how much? Minus rho by 4 pi and this is ab. So b divided by ab. So a. So this is a minus. And this minus goes in the inside. So this will become rho b minus a divided by 4 pi a. So this is the resistance of a spherical body, which is hollow from the inside, right? Okay, any doubt in this, guys? If there's no doubt, please note it down, right? Okay, please note it down, guys. This sphere is hollow, right? And okay, this portion is only this portion is sphere. And this part is from A to A, this is A, from A to A, it is. Yeah, whenever you guys want me to scroll down, please. Yeah. Okay, then please move down. Yeah, whenever you guys have noted it down, please. got disconnected. Shabe is got disconnected. Yeah, so whenever done. Noted, Tariq.
Sir, can you explain the second last line?
This one.
Yes, it's one.
Yeah, so this is the upper limit and this is the lower limit. Function is 1 by x, right?
Okay,
So,
so we did upper limit by lower limit, then we multiply it.
yeah, so then what we do is that we put the upper limit fb minus fa. This we did in here, right? And then we took the LCM of these two. So LCM would be AP, right? And then this is B is divided by AB, so we'll get A. So A will be multiplied with 1, and then B is divided, AB is divided with A. So you get B, so B multiplied with this one. So then you'll get A minus B. But you take this minus sign inside, so this would be minus A and plus B. So plus B minus A, right? So are you talking about these thing, or is there any other doubt?
No, sir, got it.
Okay, so noted, sorry.
Yes, sir, noted.
Okay, so then before we do the next question, right? First, let us understand about these, right? So let's say if this is, right, if this is the theta, right? So what is the slope of this line? What is the slope? Slope is tan theta, right? And tan theta is, let's say, y by x, right? Is this clear? Yes, we know, right, Tariq? Yes, Tariq, am I audible? Hello, Tariq, can you hear me?
Yes, sir, but your voice is a bit low, it's not
No,
heard properly.
my voice is low.
Yes, sir, a bit low.
Is that so? I have increased my volume to 100%. Yeah, this is 100%. So is it still low? Is it still low?
No, sir, no, it's okay.
Yeah. So I was talking about this. Yeah. Yeah. So I was talking about this slope, right, of this line, which is given by y by x, tan theta, right? And let's say I extend this line. Let's say I have this line and I extend this line. So let me draw it like this. I extend this line, right? And this is my, so this is, and then what happens is that this is, so, so this is my tan theta, right? This is my tan theta, and this, let's say if I want to calculate the slope at this point in here, so this would again be tan theta, right?
Yes, sir.
And from here to here, this is A, right? From here to
Yes,
here, this is Y. So from here to here, what would be this?
X.
No, no. So I'm asking about total is from here to here, total is Y. And from here to here, from here to here, this is A. So what would be this?
Y minus.
Y minus A. Good. And let's say this distance is whatever, B, right? So tan theta would be how much? Y minus A divided by B. Clear? Is this clear? Did you understand this part? Yes, Shaviz, did you, yes, Tarif, did you understand this part? Hello, Tarif, can you hear? Yes, Tarif, can you hear me? Hello.
Can you repeat again? My Wi-Fi is
Yeah,
not.
yeah, yeah, yeah. So I was talking about, yes. So I was saying that this total distance is y. This distance from here to here, this is a. So this distance would be y minus a, as you said earlier, and this distance is b. So tan theta again would be y minus a by b, right? This part clear.
Yes, sir.
Now what I do is that I have this kind of structure. So I have this structure, and this is let's say this is a, and let's say this is b, and let's say this is c, right? And this is my tan theta. So this would be theta, and this would be theta. Is this part clear?
Yes, sir. Clear.
So now you tell me, if I take this triangle, right? Let's say from here to here, this is let's say M, and from here to here, this is N, right? Or let's say from here to here, this is N. So then if I calculate the slope, this triangle, if I calculate the slope of this triangle, so that would be tan theta, and this would be how much? What is this thing? How much is this?
Theta minus B minus theta.
B minus A. This part is A, right?
Yes. So
Total is
B
B.
minus yes.
B minus A divided by M.
Mm.
Clear?
Yes.
This is clear. Similarly, I have this in this triangle, right? In this triangle, tan theta would be, how much is this distance? Or let's take this triangle, right? Let's take this triangle. So how much would be this depth?
C minus B by M.
So C minus A. This is
Yeah, C minus A by M.
yeah. So C minus A by this much. This is N, right?
Is it N or M?
So from here to here we are taking, right?
Sir,
From
N is down, right? Not M.
N is this level, right? So this
Okay.
would be N. This would be N, right? This bigger one is N. This smaller one is M. So from here to here, this is M, and total one would be M. So C minus A by. Is this clear? Is this clear?
Yes, sir. Clear.
So this would be B minus A by M. This would be equal to C minus A by M. So you will see that what is the use of this thing. But this you understood, right? Whenever we have these kind of structure, right? And this thing. So let's say this is A, this is B, and what is that? And this is C. And from here, this is M. From here, this is M. So I can write B minus A by M equal to C minus A by M. Now is this part clear? Because the next
Yes, sir.
question is,
Clear.
yeah. So now we can do the next question. So the next question is find the resistance of, so we have to find the resistance of a wire which is like a frustum of a, right? So so we have to find the resistance of this thrust. Okay, and from here to here, this is, let's say, A, and from here to here, this is B, and the length of the frustum is, let's say, L, right? So we have to find out the resistance of this wire. Clear? Is this question clear? So we have a frustum like right. This is the glass, and this is the uh, bigger bigger surface. This one is the smaller. So this one is the smaller. This one. This is not the hollow one. This one is the bigger one. So we have this kind of a wire, and we have to find out the resistance of this wire. So is this clear? Sorry.
Yes, so what you're not screen sharing.
Yes.
So you're not sharing the screen earlier.
Yeah. So I was talking about yeah, these. So this kind of shape I was talking about, and we have to calculate the resistance of this shape, right? So what we do as we did earlier, so we will take a strip, right? We will take a strip and very thin strip. So this is of length. This is of length dy, and from here to here, this is y. Okay, is this clear?
Yes, sir.
So we are taking a very thin disc, right? And this length is x, and its strip length. This one is dx, right? So now this is the same kind of figure. So we can write the small resistance dr. This would be rho, and the length between this strip is dy, right? And then this is divided by what? Area. Area would be how much? This is what kind of area? This is a
Yes, sir.
circular. This one is the
Yes, sir,
circular area,
DX.
right? So no, this area I'm talking about, the cross sectional area.
DA.
Yeah, pi x square.
Okay.
Because this is like so I have taken
So I thought
circular.
you meant the area, not the formula.
Yeah, so the area of this cross section I'm talking about, right? Yeah. Oh, so you are talking about rho L by A.
Yes, I like that.
Yeah. So area of cross section is pi x square, right? Because this is circular. Here, is that clear? Yes, Tarif, is this clear? Yes, Tarif, is this clear? Did you understand this part? Why this would be this? Maybe you are not audible. Yes. Hello, Tarif, can you hear me? See, your mic is not working properly. Yes, Tarif, can you hear me? I guess your mic is not working. What is that? Yeah, you can please, so you log out and then please rejoin and then see if it fixes your mic. Yeah, can you hear me now, Tariq? Yeah, your voice is breaking. Maybe there is some internet issues, right? Yeah, there is some internet issues. So maybe your internet is not working properly. Yeah. Okay, so did you hear what I was?
So can you repeat?
Yeah. So I have this. So I have taken this circular cross section, and
Yes,
this has a very thin length dy. Right. So this length is dy, and this circular cross section is pi x square. Right.
yes, sir.
And but this length, which is this length between these strip, is dy. Right.
Yes, sir.
And the function is x, and this x is going from this A to this B, right? This is
Yes, sir.
the length it is going. So now I have to change this dy to this x, right? Because the
Yes, sir.
function should be dx. So this wire is increasing in this length, and it is also increasing in this length, right?
Yes, sir.
So now I have to relate this y, this y with x. This is what I have. So again, remembering the
So 1 minute,
derivation.
I'll be back.
Yeah, of course, of course. Yeah, please. Yeah, please. Yeah. So did you come back? Sorry, for there. Yes. Whenever you have returned, yes, Tani. Whenever you have.
Yes, I am back.
Yes. So as I was talking about, so just like we derived. So now you will tell me the relation. So we have to find the relation between y and x, right? And we have this diagram. So you will tell me that what would be the relation between. So from here to here, right? This is my x. This is a. This is b. From here to here, this is y, and from here to here, this is z. So what is the relation that we got? What would be that? From the earlier result, what would be this? This is the diagram, right? Yes, Tariq.
Yes, sir.
Chavez has. So what would be the relation here? That would be, if I write, please correct me if I'm wrong. So x minus a divided by y,
L, yeah, y.
this would be equal to,
X minus b by y.
no. From here to here, from
No.
this one and
B
this one.
minus x by y.
B minus and this one.
B minus
A,
a by y.
L,
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 okay. So is it y or
right?
L?
This one is L, right?
Oh,
From here to here. So just look at this, whatever we did here. So this was B minus A divided by M, and then C minus A divided by. This was what we got, right? So similarly, we have used that in here. So this is the result that we get. Is this clear? Yes,
yes,
is
sir, clear.
yeah. So now we have got a relation between y and x. So let us write in a proper manner. This would be y b minus a divided by L, and this is x minus a. So let us differentiate this with respect to x. So this would be how much? This b minus a by L is constant. This would be dy by dx, and this is dx by dx, which is 1, and this is 0. So this is a constant, so this would be 0. So we will get dy, and this would be equal to dxl divided by b minus. So is this part clear?
Yes,
This
sir.
is so now we have changed this dy to dx, right? So what was this integral? So integral was this one. So integral was dr, and this was rho dy divided by pi x square. So this is rho, and L dx divided by b minus a pi and then x square. Now I have this x variable, and this is the function of x, right? So now we can integrate this quantity. And the resistance would be integration of this quantity in the limit of x. So what is the limit of x that we are having, right? So the limit of x is from a to rho L by pi b minus a is taken outside. This is a and b. This is dx by x square. So again, as you guys have came across this result, so this is rho L by pi b minus a, and this is minus of 1 by x. Then this would be rho L and pi b minus a, and minus of 1 by b minus 1 by a. So this would be rho L by pi b minus a. LCM is BA, minus is multiplied, and then this is A minus. So this minus and this A minus V will become B minus A, and this is pi B minus A and A. So this cancels, and the resistance of this wire with a different radiuses would be this. So this would be the radius, right? And let me, the Chavez got disconnected. So Chavez, did you note down this part, or when did you get disconnected? So did you note down this part? Yeah, I guess Shahid might be small. So both of you guys, also, so your mic is not working. Yeah, from question. So this was the question, right? So this was the question, and this when we were doing this question, so you were there, I guess, right? So now after that, we talked about this relation. So we talked about the slope, which is y by x, and then we have these kind of slopes. We talked about that. What is the slope of this? The slope of this thing would be y minus a and divided by b. So this we did, and after that we talked about the slope of this kind of. If we have this kind of geometrical structure, then what would be the relation between A, B, yeah, yeah, from slope. Okay, yeah. So from slope, yeah. So this is what we did, right? So slope is tan theta, which is y by x. Now we are calculating the slope of this quantity. So slope from here. Okay. So to calculate the slope from here, we calculate this thing, and then we calculated this thing. So this was y minus a divided by b. So this was this. Again, what we did was that we had this kind of right. So first we calculated the slope of this thing from here to here. From here to here, this part is A, whole part is B, so this is B minus. This is B minus A, and from here to here, this is N. So slope is B minus A divided by N. From here to here, this triangle we took. And after that, we took this bigger triangle, right? So from this bigger triangle, this part was C, and from here to here, this is B. No, this is A, right? From here to here, this is A. This is again A. So this was C minus. And then to calculate the slope, so this is the triangle. So again, tan theta would be C minus A divided by this length. This is N. So again, both the slopes are equal. So this is the relation that we got. Right, Tarif? This is what we understood, right?
So can you repeat?
Oh, so you didn't understand. So this we discussed with you, right? Okay.
No, sir,
So
like
yeah, what? We have this kind of structure. Okay, and this one and this one, and we have in the middle this length. So let's say this length is A, this length is B, this length is C. Now this length is M, and this length is N. So first we calculate the slope of this triangle. Right? Let's say this is theta. So then in this triangle, this length would be B minus A, and this is M. So then slope is B minus A divided by M. Correct? So who got disconnected again? Yeah, so Tarif got disconnected. So Shavez, did you understand this part? And then we are taking a triangle which is this one. So then we are taking this triangle, and again in this triangle, this length. from here to here, this is A. So this is C minus, and this length is N. So tan theta would be C minus A divided by. So both the slopes are equal. So B minus A divided by N. This is B minus A divided by. So this is the relation that we need. So what are you saying? Oh, yeah. Okay, so this is the relation that we proved, and then we calculated the resistance. So this was the question. Yeah, so the question, Chavez, was that we have a wire whose one end is of radius. This is some kind of a frustum of a cone, right? So this is a frustum, and then we have this smaller radius is A, bigger radius is so we have to calculate the resistance of this wire. So what we did was that we assumed this cross-sectional area and then a very thin distance dy. So length is dy, and area of cross section is pi x square. This is the area of cross section. So this is the small resistance. This one, and this is the same diagram that we are getting, right? If we extend this, so this is the same diagram that we are getting. And we change this x and y, a and b, and this is the relation that we got from the earlier. And then we found out that what is dy with respect to x. So this is the relation that we got, and then we put the value and then we integrated this quantity. So this is how we got this resistance. So any doubt in this question? Any doubt in this question, Shavis? Yeah, so okay, so please note down this part. You will not need this part, so again, note down. This is the first diagram. This is one, then this is two, and below one is the third one. So this one is the same as whenever you want me to scroll down, please. Where did Tarif? Oh, Tarif, you have come back. So, Tarif, you also please go down. Do you have any doubt?
No,
Tarif?
not much, sir.
Okay. Yeah, please note it down, guys, and then we'll do one question, and I want to start EMF, right? Combination of cells and all those things. I want to start it today. Quickly note it down, and then we will start this EMF. Yeah, whenever you guys want me to scroll down, please. This part you guys have put it down, right? So then this is the equation. This is the equation. You have to calculate the resistance of this one. This is the wire that you have. Custom like a switch. And who got disconnected this time? Tariq got disconnected. Yeah, whenever you have noted it down, Shavit, please
Can you scroll a bit up?
Oh, so a bit up, you said.
Yes, sir.
Uh,
Yes, sir.
yeah.
Yes, sir. And you can scroll down.
Okay, so your network is fluctuating, Tariq, right?
Yes, sir. Today's a sensitive.
Yeah, yeah. No worry about it. Whenever you guys want me to scroll down, please tell. Noted, guys, should I scroll down?
Please scroll down.
Scroll down. Yes, did you say scroll down?
Yes, sir.
This minus is in the multiplication, right? This is multiplied. Yeah, whenever you guys want me to scroll down, please. Good, guys. Whenever Tarif you have noted it down, please let. Think of what. Yes, so Shavis, we have already noted it down. So now let us do a last question on resistance, right? This type of typical question you guys are. So find the percentage change in resistance when the uh, when the length of the wire is stretched, let's say 2%, right? So we have this wire whose length is, let's say, L, and area is A, and it has been stretched, right? So then it has been stretched, and it has, yeah, and then it has been stretched, and its length has increased by 2%. So this is a very big one. So this is L prime, and area also has changed because if we are stretching, then area will be smaller, right? So area has also changed. Now we have to find out that what is the percentage change in resistance. So we have to find out that what is R prime minus R divided by R into this we have to find out. Right, Shavis? Oh, sorry if you have come back. Your network is fluctuating. Yeah, so this is these kind of question you guys have done many times, right? So what do we need to find out? We need to find out what is L prime, what is A prime, right? Oh, again, what happened? Again, I got it. Yeah. So R is rho L by A, and R prime is rho L prime by A prime. Because it is the same material, that is why this resistivity is same, right? So first we have to find out L prime. This is given that the length has been increased by 2%. So L plus 2% of L. So this is L plus 2% is how much? 2 by 100 into L. So this is L plus 0.02 L. This is 1.02 L. Right, this is our L prime. Okay, and how can we get this area, Shavis? If you can unmute yourself, how can we get area prime? So area prime we have to figure out. If I get this or if we get this, then we can calculate this resistance prime. So how can we calculate this area prime? A by 0.0. Okay, yeah. So that we have to check. We can calculate this area prime by calculating the volume. So volume will always remain, right? Volume will be same, right? Because yeah, if we are changing the length, so the area will be changed like that. So this area into length of this previous, and this would be equal to A prime L prime. So A is A, L we know, right? A prime is A prime that we want to calculate. This is 1.0. As you see, L will cancel and A prime would be A by 1.0. Okay, now we have A prime, we have this L prime, so we can calculate what is the R and what is R prime. So R prime is rho, L prime is 1.02 L, and A prime is A divided by 1.02. So this would be how much? This is rho L by A, 1.02 square. So how much is that? Let me calculate how much is 1.0. This is 1.0, right? So this is 1.04 rho L by A, right? So this is how much? So rho L by A is R. So 1.04 and R. This is the new resistance, right? Then if we calculate the percentage change, so that would be R prime minus R divided by R into 100. So this is 1.04 R minus R divided by R into, this is how much? 0.04 R divided by R into R cancel, and this is 4%. So percentage change in R is 4%. This was a very simple question that you guys maybe you have done this in your CBSE. So did you guys do this in the CBSE course? Yes, Shavis, did you do that in CBSE?
Can you scroll up?
Yeah. So yes, Tariq, you have returned back. Yeah.
Yes,
So
sir.
we are calculating the percentage change in resistance when the length of the wire is stretched to 2%, right? So we have this initial wire, its length is, oh, it was easy than the question. Yeah, so, okay. Yeah, so we have this length of the wire, and this is the area of cross section. And then we stretch this wire. So its length is increased, but its area will decrease, right? So to calculate the percentage change, we have to find out this quantity, R prime. R we know that is rho L by A. R prime is rho L prime by A prime, right? So we have to figure out L prime and A prime, and then we calculate the percentage. So please note it down, and if you have any question, please ask. The only important thing to remember in this that the volume of the wire will be same. Right? Volume will not change. Yeah, please note it down, and if you want.
For L dash, how did you get to 1.02?
How did we get 1.0?
Is for L dash.
The length.
Yes.
Yeah, so this is L plus 0.012. So if I take L common, so this is 1 plus 0.0. That's this is 1.012. This is what you were asking.
Yes, sir.
Yeah, whenever you guys want me to scroll down, please.
Can you scroll down?
Yeah, whenever you guys have noted it down, please. Yeah.
Sir, noted.
Okay, so then now let us do this. So now the resistance part is over. Now we have EMF, internal resistance, and a combination of right. So we have what is this EMF? So we have a cell, right? And we have this electrodes, right? And then this is the electrolyte, and then we connect these two. So then we'll get a supply which will create some EMF, and then we'll get the EMF from this, right? So in chemistry, you will learn that what is this photovoltaic cell, or what is voltaic cell, and what are all these cells that, right? So this cell will generate some EMF, but due to this electrolyte, there will be
This
some.
Daniel cell, right?
Yeah, in electrochemistry you will learn this. Yes, in electrochemistry you will learn this, and this cell will give you some EMF, right? So the highest potential difference between this higher potential to this lower potential. So this is the higher potential, and this is the lower potential. So the difference between this higher potential and lower potential will give you the max EMF, right? So this is the EMF, and due to this electrolyte, you have some internal resistance, and that is denoted by R. Right. So this is the structure of a cell, right? And then when you connect it with this external resistance, right? So when you connect this with this external resistance, this is EMF, this is internal resistance, this is the external resistance. And the current is flowing in this direction, right? So it is going. and coming back in this direction. So there is this terminal, right? So there would be some terminal voltage difference across this resistance, right? And we know that this is connected in series, so the R equivalent would be R plus R, right? So current would be E by R plus R, right? And this is equal to, let's say this is so let's say if I take this term in this side, so this is IR plus IR, and this is the EF. So this is the voltage across this term, right? V. And this would be equal to E minus I. So this is the terminal potential difference, right? This would be equal to E minus I. Okay. And graphically, how do we show this relation? Right, so graphically, how do we present this relation? So we have this. This is V and this is I. So you want to make a VI graph, right? And you guys have mathematics, so you guys have learned about the straight lines. What is the equation of the straight line?
Y is equal to mx minus p.
Yeah, y is equals to mx plus c, right? Y is equals to mx plus c, and you can write this. Yeah, y is equals to mx plus c, where this m is your slope, right? And c is the intercept. Intercept where this c is where your x is 0, right? And y-axis of this line, straight line, is cutting the y-axis. So that is called this intercept, right? So if we compare this y with this equation, v equal to minus IR plus E, right? So what is the slope? Slope is minus R, right? And our intercept is E, correct? So slope is negative, guys, right? If the slope is negative, then graph would be like so let's say this is my, so the slope is negative, so this would be graph, right? And this point is, let's say this is my current, this is my voltage. So this point is the intercept, right? So this is E, and this point is where my x, where my y is 0, right? So v is 0, which means that v is minus IR plus E. This is 0, right? Plus E. So this is E equal to IR. So I would be E by R. So this point is E by R, right? Where your current is maximum, right? And the slope which is tan theta, we can write it as minus of R. Is this clear, everyone? Are these things clear?
Yes.
Yeah, so please note down this part, and then we, so this thing you guys put it, yeah, so please note down this part. This part is not needed because this is electrochemistry. So all just remember from this point. Yeah, so in your electrochemistry, what kind of cells do you guys have? So you guys have done? One would be the voltaic cell and the Daniell cell, right? All these cells you guys have done. In physics part, we are just concerned with that how much EMF that cell is generating, right? Okay, so please note down this one, right? And this is very important, right? So whenever we will have combination of resistances, so this relation combination of cells, so this would be the result that will always be. So always remember this point, right? So if we, when we write the current for different kinds, this would be simply E equivalent by R plus R. These things. Whenever you guys have completed everything, then we'll do one question from the graph, and then then some special cases, and then we understand about the combination of cells. So whenever you guys have noted it down,
Yes.
done. Chavez, what about you? Now let us do a very simple question. First, let us start with a simple question. So VI graph is given, right? You have, oh, so you didn't note it down. Yeah, sorry, sorry. So VI graph is this okay, Chavez? Now the question is that you have a VI graph which is given. So this is like this is 6 volt, and this is V and I graph, and this point is 2M. So the question is that you have to find out. So question is that what is EMF, and the second question is what is the internal resistance. So from the graph, we have to tell what is EMF and what is the internal resistance, right? So EMF we can calculate easy. That this whatever is the intercept, that is the EMF, right? So EMF would be how much? Yes, guys. EMF would be 6 volts, right? Yeah. So EMF, absolutely correct, Shams. This is 6 volt, and now we know that this point is maximum current, right? Which is 2 amperes. Oh, minus 3 ohm. Why minus the right? Yeah. So minus resistance cannot be negative, right? So the slope is negative. Resistance is not, right? Yeah. So this point is E by R, right? I max is E by R. So this is 2. And we know that this is 6 by R. This is 2. So this R would be 6 by 2, which is so R is not negative, right? Yeah, you are absolutely correct, but the sign would be positive. So is this clear, Tarif?
Yes, sir, clear.
Yeah, so please quickly note it down, and then yeah, we have 3 minutes more. What we can do is that yeah, we can talk about three special. Whenever you guys have noted it down, guys put down. Yeah, so this part you guys. Yeah. Okay. So what we'll do is that we'll stop at here, right? And we'll
So one more time
continue
writing.
from. No, you are right. Yeah. So, no, we are not ending the class right now. But we'll stop it here, right? Then we'll start in the next class. We'll understand about combination of cells, Kirchhoff law, and we can add some resistors and capacitors to this one. Yeah. So then this chapter. And then we'll move on to the magnetism. Right? Magnetism after magnetism. Magnet, magnetism, Earth magnet is not that big one. That is not too much time. Electromagnetic reception, that is also a small one. All these are small channels. These we can. Yes, Tarif noted.
Yes, sir. Done.
So, Allah Hafiz guys, and see you guys in the next class. Okay. Allah Hafiz guys.
Thank you, sir. Allah